Hey there, Russ here. Welcome back to the shop. Well, this is going to be the best view you get. Yes, it's me. There's my ID. But I wanted to talk to you about my electrical setup. Dave was right. I probably should give you a closer look at what I did. Um, this is all has to do with my power station that I'm building. A 6,000 watt inverter is going to run my whole house if the power goes out. But and in the same way, I can plug my generator into an outlet, and then turn off the main breaker, and I can backfeed the house from that generator full power. I want to be able to do the same thing with my power station. It's a 240 power station, so I can plug it into my circuitry of my house, and I should be able to run everything off of the power station in the same way that the Delco and the Blue Eddy and the EcoFlow, how they double up on two batteries to give themselves 240 volts. Mine's already set that up, and then they plug that into a plug-in, the same plug-in that the 240 volt generator uses. It's a NEMA plug-in. Now, you need a positive plug-in in order to plug in the cord to the house to be able to backfeed. This is identical to the one that's over where my generator is tapped in to be able to run the generator on the backfeed the house. Now, first off, let me say it's a given. If you're going to run any of this equipment and power your house, you need to make sure you're off the grid power. You have to turn off your main breaker at the main panel in your house so that there is no power anywhere. With that in mind, if the power goes out, I turn that power off. I want to be able to have power from either my power station or the generator. The generator I plug into a plug-in like this, and I flip that breaker on with the generator running, and it will feed the whole house off of that generator. But instead of hooking up the generator, much quieter is to hook up my power station that I have here, the 6 kilowatt inverter on it, and it has 15 kilowatts watt hours of power. So I should be able to run the house for at least 12 hours and maybe longer, depending upon how thrifty I am at spending that 6,000 or that 15,000 kilowatts. Anyway, with all that in mind, the hookup is what I'm talking about. In order to plug in from here in the shop to power the house, I have to go through my sub panel here. This is the main panel on the garage here that comes off of the house. There is a 30 amp breaker on my main panel in the house that sends 30 amps out to here, and all the power in this building is distributed through here. So the problem is I have to change this out really to do all of this properly, because this has a couple of problems with it. First off, it doesn't have a master power on and off breaker. This is a true sub panel, and it should only be used within the same building that the main panel is in. So this is supposed to have its own breaker. So anyway, knowing that I have to change this out, the other problem I have with this is the power on it. I only have 8 slots for power, to put breakers in to run power distributed out, and only one 240 breaker is in here. So that means that I have to use this breaker to plug in my generator if I'm going to run off of either generator. So I need actually 2 more added to this panel. Well, in order to do that, all I did was very simply, I'm going to take this breaker, I pulled the AC out, the wire that ran to the AC circuit over to the other side of the shop, and I put it into this box here. Then I took some 10-4 welding cable, and I bought a 10-foot piece, and I cut it into sections to be able to do all these 240 connections. I'm not going to get into how to wire a 240 outlet up, but I'm just showing you the schematic of how I did this so that I can now make use of my power station and plug it into the house and be able to supply the whole house from here. So that's what this plug-in is for. So in order to have that secondary panel, I had to take this power switch, and instead of running to the air conditioner, I'll have this power this whole load center, which is basically the same thing as this. So I'm taking one breaker and feeding it over here. So if I turn that breaker off, there's no power here whatsoever. If I turn it on, then there's power here on all three of these circuits, these 240 circuits. When I turn these on, then they have power. I will control this panel because each of these do different functions. This one goes to the AC, which used to go here, but now since this runs the whole load center, I put that one here. But that gives me two more places that I can put outlets or put other circuits. In this case, that's what I need. I needed two circuits. So this thing is just the right size for me to add two more switches onto the load coming in. But since I didn't have the space here, I was able to switch it over by using this to give power to this whole center. This is kind of like if I had two extension cords, plug one into the wall, and I plug everything in, and I need 8 outlets, and I only got 6. What do? Well, I take and I unplug one of those appliances, plug the second cord into it, and now I have 5 outlets left plus 6 new ones that I can plug into. So now all of a sudden I have 11 plug-in outlets all in one area. Now keep in mind, it doesn't mean that you can run all sorts of power you want. Those 11 outlets should not have any more power running through them than what the 6 would have running through it to begin with. Not all power being drawn is the same, so you just have to watch how much power you're pulling through that to make sure that you don't really go over. Now I do know that my power station only puts out 6,000 watts, and in the AC world, 6,000 watts basically is 25 amps. So as long as I'm using 30 amp breakers, my power station can never put out enough power to cause one of these breakers to pop, theoretically. So, except for when it goes under a super load. I think I have an 8,500 watt surge on it, and I forgot how many seconds. So, but a breaker itself usually won't pop the minute it goes overload. I don't know how all that works, but it doesn't matter because I'm not going to be pulling that kind of power to go over the 6,000 volts. I know that's my limit, and that's why I make sure that when I manage turning things on and off, well, to be sure that I stay under that 6,000 watts that I'm supplying to the system. The same thing holds true with the generator. My generator will put out 7,000 watts, theoretically, but I can only really put out 30 amp circuit worth. So I'm not going to overload it as long as I'm working everything within a 30 amp circuit. Everything should flow without tripping breakers or shorting things out and burning them up or overheating the wiring or anything. So I am working basically on a 30 amp theme. That's what my power station is going to be, less than 30 amps, and all my breakers are going to be 30 amps, so I should not have any overload problems unless I'm turning things on and doing things at the same time. So then, why do I have 2 outlets here? I mean, 2 switches. One for this one and one for this plug-in. This one, it goes to the air conditioner. I can turn it off. When the grid goes off, I don't use air conditioning period anywhere. Not here and not in the house. I don't have enough power, storage power, to be able to replace running something as large as my air conditioners. So when the power goes down, I'll have power to do virtually everything else except run my air conditioners. And for now, that's good enough because that means that I only have to spend about $7,000 for a power station instead of spending $25,000 or $30,000 to be able to have enough storage power and output of watts in order to run air conditionings. It's not worth it to me at this point. So we're working on a smaller scale and eliminating the use of air conditioners when the grid goes down. So everything here is based on 30 amps is all it is. So what I did was I took the wires that plug in, that hook up to this breaker, and I ran them over, and I run them to the load center, the main connectors on the panel, to give the panel full power. Then I use each individual breaker for the different circuits, the AC, plug number 1 and plug number 2. Plug number 1 is for my output of my power station. I would plug it into here using the female end of a power cord to plug into it. Now my power station will also have an input on that inverter, and on that one I'll have the other end of that extension cord that I cut in half, and that will be the male plug-in. And what that is for is that when I have electric power and things are running, but I want to keep the battery charged up, or I want to charge the battery up on those batteries, that means that I have to have power here. Then I would turn this one off because I won't need it, because I'm getting power from either the generator or from the grid. I can plug this power station into here, and it will control charging my battery up to full charge. Now I do have solar capability on the all-in-one inverter on my power station, but right now I'm not going to do that, because this is just here to provide power for survival when I'm not on the grid. I'm not trying to become off-grid permanently or anything like that, or try to save money when I'm off-grid. All I'm trying to do is to be able to function when I'm off-grid and not lose the important items I might have here that will be a problem if I don't have power, like my freezers and refrigerators, or like heat. If I have to heat the house, I'm on natural gas, but I still need electric power to run the furnace in both the shop and the house. So those are not extreme pulls of power like air conditioning, so I'll still be able to use everything except my air conditioners. And I know I'm rambling on, but that's basically how this is all set up. So that's why I put it up this way. Now eventually I do have to replace this. There were several mistakes made within this first original circuit that was put in here, the sub panel. First off, there's no main breaker, and it's in a separate building. The only way I can turn this power off to this building is I have to go into my main house and hit the breaker there on that main panel. There's a circuit breaker dedicated for just out here. That's the one I would turn off, not the main breaker on that panel. So I would have to turn that breaker off to eliminate power here and still have power in the house. So the only way you can cut the power here in this building is in another building, and that's what I don't like, and I think it doesn't meet any codes out there that I'm aware of. So that panel needs replaced. It has a couple other shortcomings, which I don't know how big a deal it is to you, but this is only a 30 amp circuit. She's all excited about something. This is only a 30 amp circuit coming in. Why they would put 30 amps into a garage instead of giving it any real power when he knows, because he turned this into a paint shop while he was here. Why he tried to run that off of 30 amps, I'll never know. Anyway, if I was going to put in something, it wouldn't be less than 60 amps. Main power coming in, but I can't change that. The third problem is that he didn't bond and connect all his grounding and his neutrals in the proper way in the box, and that's electrician talk. You don't need to know. I just wanted to show you the change I made. So I basically took one of these plug-ins, took the wire off of it, brought it into this box, and then I put 3 switches in that run off of this switch. So instead of just turning that off, I now turns off all 3 of these at one time. And I will control these based on which one of the 3 circuits I'm using for whatever I'm doing. And I will control that myself. So this is a good temporary solution. This load center was less than $30. It's going to have to go away. I'm going to have to put a main panel here and get rid of this and rewire this whole thing. So this will get me by, so that I can hook up my generator to here if I want, or I can hook up my power station to here and power the house by backfeeding it. I know how to turn the switches on and off. This is not a play and go thing for somebody else. You do need to understand what you're doing, but basically, if you have a generator plug-in on your house and you use a generator, but you want to use some kind of solar generator instead, the unit I'm building will plug into the same outlet that a generator plugs in and give you the power without all the noise that a gas generator might give you. So that's the theory. This is where I'm going. This is now ready. I can now put this panel back on here, and I can safely use this to plug my power station in, because I needed this, because first thing I got to do when I get that all hooked up is I got to be able to plug into this, because I got to charge those batteries up, and the only 48 volt charger I really have of any practical sense is the one in the all-in-one. So I have to be able to plug into this outlet here. I now can turn this one on, turn this on, and I have 240 volts here to be able to plug my input in on my power station and charge my batteries off the grid. So anyway, that's kind of how this whole thing works. I hope this explains it a little bit better. I didn't show you how all the wiring of how you hook up the line 1 and line 2 and the neutral and the ground, and how those all should come together. That's an electrician type stuff. You should get your advice on how to actually wire things up. If you want to wire this circuit in, you need to learn how to do that. And I cannot, that's not what this is about. This is the basic circuitry of how I set up to be able to add more capability and be able to use it and safely use it between this limited panel and now with this extra panel. I should be able to power everything that I need to power, even when the power goes off, theoretically. So anyway, I hope this answers the questions, Dave, that you had. If you guys have any questions about anything, let me know. And like I said, don't follow my advice. Always look to an electrician if you don't know what you're doing. This is all just a temporary setup for me till I can get that thing up and running. And then once that's up and running, I'll come back and address all this and make it proper so that I don't have to worry about it. So I just wanted to bring you along and let you know what I'm doing to build my power station. Power station doesn't do any good unless you can plug it into the house and use it. So anyway, that's it in a nutshell. Questions and comments, leave them down below. I do read them all, and I enjoy reading them if you have any knowledge to share. If you learned something here, you like this video, hit that like button. Lets me know I'm doing something right. Most importantly though, please come back again, because I'm nowhere near done. And I'm sorry about that little humming sound. I forgot to unplug this little fan on my camera, my Surface, Microsoft Surface tablet. And so this little fan, you might hear that kind of rumbling and the low rumbling in the background. Sorry about that. I should have unplugged it. I don't want to do this video again. So there was a lot here to give, and hopefully I got it out in a way that makes sense. So just deal with that. I'll try to remember to unplug that from now on. So anyway, thanks for coming by, and we will see you again very soon, I hope.